Hi, in this video I'm going to explain a little bit about the scientific method. Scientific method is something many people know about and oftentimes have a challenging time expressing their knowledge to others. So let's take a deep dive into the scientific method and see what it's all about. Scientific method is one approach to acquiring knowledge. It's not the only approach, but it is one. And it is also a very inefficient way of learning about the natural world. Uh, some questions will lend themselves nicely to a scientific approach to seek an answer, and others may not. The kinds of questions that lend themselves well are those that can be answered on the basis of observation and analysis. These are two key elements: being able to look at something, see what happens, and analyze why that may have happened, what sorts of variables may have been involved in controlling what happened, etc. That goes into the analysis. Other key characteristics of the scientific method include, of course, observation, which we talked about, a hypothesis. Hypothesis is very important. In many ways, it's the most important step in employing the scientific method, is the formulation of a hypothesis. And then, of course, there's experimentation, and then perhaps eventually the formation of laws or theories. So let's take a look at observations. Ironic. An observation, sometimes that's known as data. So these are descriptions of characteristics. Here's an example. Antoine Lavoisier noticed that there was no change in the total mass of material within the container during combustion. So he placed some material inside a container, set it on fire, and saw that the container did not change mass, even though the material inside changed significantly in its appearance and composition. So this sort of an observation might lead to the formulation of a hypothesis. In this case, Lavoisier might have hypothesized that in a chemical reaction, mass must be conserved. So let's take a look at hypotheses now. What is a hypothesis? Well, it's a tentative interpretation or a way of explaining observations, but it's actually more than that. A hypothesis is a definition of some sort of scientific question, and that question must be testable by using scientific method. If you can't test it using scientific method, it is not a scientific hypothesis. It sounds circular, but that really is the definition. So, for example, based on Lavoisier's observations, he may have concluded that something is happening when something burns that changes the composition, and perhaps he says, you know what, I think that that is because it combines with something in the air. Okay, so now this is something that would be testable. So, for example, what Lavoisier might do is attempt to combust something in a vacuum where he's removed all of the air, and may notice, it doesn't combust. Or maybe he does notice that it does combust, in which case he would have to go back and revise his hypothesis. And that's an important point. A good hypothesis is always falsifiable. That means that it has to suggest an experiment, the results of which could produce results which show that the hypothesis is not correct. If you cannot do that, if a hypothesis does not suggest an experiment, the results of which could prove the hypothesis incorrect, then you cannot test it scientifically, and you're not employing the scientific method. It's a very important point. Okay, moving on. So once we've taken a look at a hypothesis, maybe we've done many tests and we've seen that the hypothesis is reproducibly predicting what we can observe, we may take all of that information and build a scientific law. Now, what is a scientific law, I hear you asking? Well, one example of a scientific law is the law of conservation of mass, saying something like, in a chemical reaction, matter is neither created nor destroyed. That would be something, for example, consistent with the observation of Lavoisier. Scientific law is important because it allows you to predict future observations. For example, the law of gravity says that when an apple disconnects from a tree, it'll fall to the ground. Well, that's an easy thing to experiment with by simply growing apples and observing what happens as they disconnect from the trees. But this is where laws are different than, at least scientific laws, differ from state laws. You can't choose to violate a scientific law. We're kind of stuck with them. Scientific laws are just the way things are. For example, the speed of light is a fixed value. We can't exceed that, according to Einstein's theory of relativity. Gravity also, the law of gravity. That's an example. We can't escape that. Oh, sure, we could build a rocket and go into outer space. Maybe launch a Tesla into outer space. That seems to be a fun thing to do. But that takes an awful lot of work. And you still have to overcome gravity, and you will never violate that law. So what about a theory? How is a theory different than a law? This is a good question. So the other direction that hypotheses can take is that they may form the basis of a theory. And a theory is different from a hypothesis in that it attempts to explain why something happens. Not just explain what happens, but explain why something happens. And just like laws, theories are often validated by experiments. Theories can be tested. And this is very important, that a theory can never be conclusively proven. There's always the possibility that some experiment, even if it's unlikely, may prove that the theory is incorrect. So that's an important point. When somebody says something is scientifically proven, what do they mean? Do they mean that it is proven to be true? Because science is incapable of doing that. So something that is scientifically proven has to be false. It has to be inconsistent. Because that's the only thing that scientific method is actually able to demonstrate. So this flowchart shows just a quick rundown of what the scientific method involves. We make observations, oftentimes driven by our curiosity. These observations will start to reveal patterns in what can be observed. Those patterns then can be grouped into making hypotheses. Then what happens is we're going to make experiments, make observations, and then perhaps revise our hypotheses and go round and around and around until we end up with a hypothesis that is wonderfully reproducible. Then we look at the reproducible results, and that may contribute to a body of knowledge which we may want to communicate somehow. And that means that our set of hypotheses may turn into a law if they simply tell us what happens, or if we can start to put the pieces together to try and figure out why something happens, we can start to build a theory. All right, so we will stop there, and I hope that this has helped you to understand a little bit more about the scientific method.